All right, thank you. Okay, so product design and manufacturing collection includes all of these tools. Some of these tools you might be aware of. They're very, very popular, like AutoCAD, for example, Inventor, even Volt also. But there are some other tools here that are not as popular, but are very, very, very useful in the manufacturing collection as well. It's important to note what the center of the manufacturing collection is. I would say it's Inventor, design tool most of you should be familiar with. And most of these tools are included or are used from Inventor as well. All right. So if you're getting just Inventor, you're getting just the design software. It's very powerful by itself. It comes with many features, very, very useful. But with the product design and manufacturing collection, you unlock the potential for a complete design suite for virtually every need that you might have in the design and manufacturing industries. Okay. We get AutoCAD. That's like the cornerstone also of Autodesk as well. And we got Fusion too. So these three are the main products in the collection: Inventor, AutoCAD, and Fusion. And the power or the advantage of the collection is that you can handle information in either three of them, right? And you can pass information between the three of them, and you can use them depending on the task at hand, okay? So if I need to create a layout, for example, it's easier to do that in AutoCAD. If I need to design in 3D, I need to simulate. I need to pass it to a CAM software that I need to manufacture the octave part. So I would move to Inventor. If I need collaboration, if I need everything on the cloud, and I need to take advantage of all the tools that I can get with Fusion as well, well, I can send that to Fusion, all right? So in this webinar, we'll try to touch base to each one of those, take a look at how they look, what they can do. Obviously, we won't be able to see all the potential of all of those, but basically, we'll try to showcase them all right? So in the center of it all, we get Inventor, right? So first of all, I will just want to make sure that I'm showing my Inventor screen. Can you confirm if you can see my Inventor window? Probably not. I'll just refresh that. So give me 1 sec. There we go. Right, Juliana, can you confirm if you can see the little factory I get here on Inventor?
Yeah. Yeah, we see it.
All right. Right, thanks. Yeah, sometimes on these webinars, the little windows updated on the fly, but anyhow. What we got here is the design of what we're trying to accomplish. And in this case, we're trying to focus on a little part down here. Okay? So this part specifically is a part of a guitar, actually. This is called bridge, which is basically the little part that holds the strings in the guitar. And this is part of a design that we used on Fusion earlier, okay? So we'll try to showcase how we can work with this part, how we can design that, how we can include that in a factory layout, and basically everything that we can do with this part, right? So the first tool, or the most important tool in our design collection, is Inventor. Basically, I get all the tools that I need to design my part. Okay, if I need to make some modifications, basically 3D model, everything that I need for my part, I get those on Inventor. Okay, from Inventor, I can access all the other tools that I can to modify my part or to work with that one as well. So, for example, we're gonna move into our Inventor CAM tool. All right. So if we're going to use our Inventor CAM tool, this will show up as an add-on. It will show up as a little tab here on Inventor. And I will be able to manage everything that's CAM related here. If I want to set up a machine here, I want to simulate, I want to basically define how I will want to manufacture this on real life, I can get from here too. Okay, so in this case, I open my CAM tab and I got my setup here. So let me show you here how I can use this to make a setup of how I will build this part in real life. All right, so I'm bringing in here my machine. In this case, I'll use a milling machine, probably a 3+2 or a 5-axis machine in this case. And I will set up all the operations that I need to set for me to be able to build this part. Okay. So I already got some of those here. I'm going to generate the toolpaths. And I can simulate how I want to build this part, right? So let me jump here to simulate all. And after I've set up my model, I can simulate everything or how I would machine this part in real life. Okay, so I'm not focusing in how to use each one of these tools. Okay, I'm showing you what tools are there at what they can do. Okay, in this case, I started with my Inventor tool, showing you that I can model the part, basically define the design in any way I want. And now, if I want to manufacture it, I can jump to Inventor CAM. This is part of the manufacturing collection as well. So it's seamlessly included in my Inventor stuff. Okay. I'm not entirely sure if you're able to see the simulation like I'm seeing it in my own computer. You should be seeing a tool moving around the part and making all the operations on how will I create this part, creating all the pockets, making the roughing operation for most of the part, creating, drilling the holes, all of that. So maybe, Juliana, if you can confirm if the simulation is being shown.
Yep, we can see like it's making the holes, right?
Right. The ones, the horizontal. Right. There we go. Let me face here, and there we go. Okay. So when I'm done with this part, I can export my code for my machine and basically define how I want to work with this part. All right. So that's on our CAM utility, Inventor CAM. All right. Now, if I'm intending to analyze the part to check if I'm able to control or to check if the part's not gonna break under a certain load, if I want to run a fan simulation, now I would use Inventor Nestor. Okay, So see that right now I'm jumping from design and manufacturing. See that I'm using tools from the manufacturing side. I'm using tools from my design side because that's how usually our workflow goes in manufacturing, right? Um, uh, Depending on how you intend to build this, sometimes you would first design the part, maybe then you would analyze if the part's going to break, do finite element analysis or something like that. Then you would move into how you would manufacture that, right? But it's important to note this, that I'm using tools from both sides. So you can see that all of them are integrated in one single environment. Okay, so the center of it all is Inventor. So now I'm going to check on what I can do with Inventor Nastran. So I'm going to go back to my part. All right. Let's say that I make a little modification. For example, let's say that I'm using a different hole here. Say number 3, smaller counterbore, let's say 0.25. There we go. It's a little big. That one's a little better. And I want to check this new concept. All right, so I'm going to start my Nastran environment. So we get the stress analysis tool with Inventor. That's like a regular one for simple analysis. But if you want to do more complex simulations, if you want to run dynamics, if you want to run impact simulation, frequency response analysis, very complex stuff, that's what Nastran is for. Okay, so if we get Nastran, we get available this new environment. It's going to open my Nastran environment. All right. So from here, I'm able to build a finite element model with my part right there on my Inventor software. I don't need to jump to another software. I don't need to export anything. Everything is here. All right. So in this case, I'm going to load the results from previous analysis, for example. So in this case, I had another analysis before. Oh, geez. Come on. There we go. A little impatient, so that's why I'm getting this. Right, so in this case, I run analysis applying force on the tension strengths right here to check if the part's gonna break or not, right? So in this case, I'm getting a stress of 18 KSI. This part is supposed to be aluminum, so in this case, I can make sure that I'm working with a safety factor around 3, something like that. Actually, I can bring up my safety factor here. So in this case, I don't know if you're able to see that all down there. I got a minimum safety factor of 3 for my part. Okay, so I can make sure that by running the analysis, the part is not going to deform. I can use all of the tools with Nastran if I want to analyze the deformation of the part, for example. Let me bring up the deformation here, and let me just bring up some edges off. There we go. And animation options, full. There we go. Okay, all the tools that I can for analyzing, for presenting my results as well. All the power of Nastran on the palm of my hand. Okay. Let's just wait for a little bit while my animation loads up. There we go. So I can create animations showing how my part would deform. Obviously, for the people who are familiar with finite element analysis, this is overly exaggerated, right? The actual deformation is 0.001 inches, right? Which is a good deformation in this case, okay? In this case, I can create new loads. For example, you see that I made a modification in my model. So I'm going to change the load. So instead of doing applying the load here. I'm going to apply the load in a different location. So I'm going to clear this all. I'm going to apply the load here. Let's pretend that in this case, what I'm trying to do here is to analyze what happens if my bridge breaks, something like that, and all the tension is handled by the screws here. Okay. Get my loads there. I'm gonna my constraints are basically the same, but in the opposite orientation. So it should be here and there. And I need to generate the mesh again. So I made a modification. There we go. All right. So let's see how this looks. It should take a couple minutes while the analysis runs. So in the meantime, I'm just gonna discuss on other tools that I get there for the analysis of my part. Okay, so we've seen Inventor Cam, we've seen Inventor Nastron. Now let's check on Inventor Tolerance Analysis and Inventor Nesting. Okay. There we go, solution complete. Was basically just in time, right? Okay, so for this new case, you see that the deformation is a little different. Let me just bring this back here. There we go. The deformation on my part is a little different, but we still get a safety factor of around 3, right? So can make sure that under those new conditions, my part is not going to break on the analysis, all right? Finish Inventor Nastron, and I'm gonna jump into another part of my assembly. So I start from the bottom up, starting from here, and now I'm gonna check on how this looks on my factory. Okay, so let's suppose that my part it's supposed to be on this little bracket, this couple brackets here, and on a wood fixture. Right, so this should look like this. Okay, so in this case, what I'm showing here is my part. The yellow portion right here is supposed to represent the material that I haven't removed because I'm intending to grab my part to make modifications or whatever, okay? And I'm grabbing the part with 2 brackets. Probably there's a better way to do this, but this is actually to showcase other features here on Inventor, right? In this case, I got 1 bracket here that's supposed to be guided by my feature destination. Okay, so this bracket here is supposed to be flush with this channel on the wood, right? And this bracket is supposed to be flush with this other portion on the wood, right? So in this case, what I intend to do here is to grab my part between those 2 brackets and place a couple of bolts there. I'm missing actually a hole there. Doesn't matter, but you get the gist. I will just place a bolt here and a screw, so my part is held in place. But as probably you're aware, this looks very, very, very nice on paper, quote unquote paper, right? On the computer, it looks great. everything's flush, everything's really pretty. But on the actual part, on the physical world, this won't be exactly like that. Distance between this face right here and that face right there probably won't be 0.625 inches, right? Probably will be different because the actual size of that might be something entirely different, okay? So if I'm designing the part to, or if I'm designing the brackets to fit perfectly here, chances are that that's not what's going to happen in real life. So in that case, that's what my tolerance analysis is for. So this is another one of the tools in our belt on the product design and manufacturing collection. Okay, so inventor tolerance analysis is embedded into Inventor, and it allows us to run a 1D stack analysis. Okay, so in this case, for example, I'm going to create a new stack up, that is a new analysis, and I'm going to analyze how the distance between this face and that face would be depending on where the part has a certain or targets the actual distance from here to there, right? If I'm getting the actual size of the part, if this part is supposed to be 0.5 inches, what happens if the part is on real life 0.498, okay? Or what happens if the part is actually 0.502, right? For example, if the channel is narrower than intended and the part is bigger than intended, I won't be able to fit in my part here, right? So this is what invent tolerance analysis for. So I'm just gonna place my design right here. There we go. And I'm gonna check all the distances, okay? So in this case, what I'm seeing here is what would happen if the distances are not what I expect, okay? So for example, in the case, the size of the bridge is wider than intended. This is supposed to be 0.5 inches, but what happens if the tolerance is minus 0.05, that it's 5 mils, okay? So in this case, the part would be a little shorter, so probably chances are that the distance that I'm intending here is larger than what I expect, okay? I'm gonna do something here so it makes a little more sense. I'm gonna change the design so I get a little room here, okay? So I'm gonna open my wood part real quick. And just give it a little more wiggle room, okay? There we go, okay? So in theory, I should have a little clearance hit here of 0.025 inches, right? But what will happen here will be different depending on whether the part is actually that wide or not, right? So if I check my tolerance analysis, I can input the tolerance for each one of the distance involved there. So in this case, for example, the width of the bridge or the dimension of the bracket, that is distance from this face of the bracket, right? And that face of the bracket, that is the thickness of the sheet metal that I'm using, right? This is supposed to be 0.625 inches, right? 1/60 of an inch. But if it's a little wider, then I would get into trouble, right? The thickness of the second part as well, the width of the channel there. Okay, so what happens if all the conditions for this tolerance are met. Okay, so in my worst case scenario, what will happen is if I'm using, for example, the widest option here, if the part is actually 0.505 inches, right? And if the thickness here is 0.07, okay, and the inch here or the thickness here is 0.07, so that's the worst case scenario. If that happens, the parts won't be that distance won't exist. The nominal distance is 0.25, and the worst case scenario is that the distance will be eliminated and there will be an interference of 0.1 inch. Okay, so with this tool, I can check all of that. I can check all the tolerances on my dimensions, and I can do an analysis here to change that. So, for example, I can change the tolerance of my wooden fixture. I'm not going to make it symmetric tolerance. That is, this can be 0.6 and 0.7 or 0.5. No, I intend this to be minimum 0.7, right? And maximum or 0.65, right? And a maximum, this can be 0.75, okay? So in that case, I would see that in the worst case scenario, at least tolerance here or the distance here will be exactly 0. So I can make sure that my part's always gonna fit here, okay? And I can even do more complex analysis in this case. I can analyze my worst case scenario, or I can analyze what would happen with a statistical distribution, right? Because in this case, I'm ensuring that in any case, if I'm following this tolerance, my part is gonna fit, okay? But that might be a little too much for a wooden part, right? So I can run a worst case scenario, I can run a statistical case just to make sure that my tolerances will fit, all right? So that's one very, very useful tool we got there under our collection that many people are not aware of, but I think that I think it's very, very important, right? Another tool we got there is our inventor nesting tool, right? So in this case, we're gonna show what we can do with our bracket, okay? So for starters, this bracket, it's not a regular part, okay? So the sheet metal creation tools are part of Inventor. So if you're getting just Inventor, you're getting sheet metal as well. But to unlock the full potential of what you can do with sheet metal, we get Inventor nesting, okay? So in this case, I'm gonna go to my flat pattern. You see that the little bracket that I designed here, the flat pattern for it has this little shape here. But let's suppose that I want to create, I don't know, 20 fixtures, 30 fixtures, something like that. And I want to check what is my best option to place them on an actual sheet of metal and get the most out of my part. Okay, so that's what nesting is for, right? So I'm going to open my nesting file that I got here already. So this is a study on inventor nesting. So right now I'm working in the inventor nesting environment. All right, I'm showing my the shape that I want to create a nest from, and I'm showing how I can fit a certain amount of shapes in an actual sheet of metal. Okay, so in this case, for example, I'm going to pop up my process material library here. I have metal sheets of steel, carbon steel, with a size of 48 inches by 12 inches. Okay, so this represents the actual metal sheet that I have available in my factory. And with the study, I'm analyzing how I can build my part, and I can optimize the orientation. I can optimize the shape of the amount of parts that I want to create. Okay. So I'm gonna let's see. properties. There we go. So let's suppose I need to create, I don't know, 7 sets. So you see that I needed two brackets per fixture. So I need 14 of these parts, right? I want to create a study for that particular shape. I'm going to use this packaging. And what I want to do here is minimize the length that I'm going to use of my metal sheet, right? I can optimize this in some other ways as well. Actually, I'm going to bring this here because when this is maximized, you're not able to see the options there. Oh, geez. Well, anyway, this is, I'm trying to do the drop down here, but the options are shown in my other screen. So anyway, we got minimizing length, minimizing my width, or minimizing the whole area. Okay. So I'm going to run minimizing the whole area. That is minimizing length and width. There we go. So in this case, if I want to minimize these two distances, this is the way that I need to set parts in my metal sheet so I can make the most out of it. And inventory nesting is going to analyze my efficiency, how many parts I get, how much is lost. And if I fill in all the information, I can even calculate how much this is going to cost as well. Okay. So this is a very, very useful tool we got under our belt here on Inventor, on our product design and manufacturing collection, right? Close my bracket here. And I'm going to jump into larger scale. Okay, so we've seen all the design from the part point of view, but what if I want to do something bigger? I want to set up my factory. I want to set up my machines. I want to look how I can manage all of that. Chances are that one single person is not going to do all of this stuff, but what the collection is there for many, many types of collaborators, right? So in this case, I'm going to show you how I can manage my information of my factory on a larger scale, okay? So in this case, I'm using a model that includes all of my assets there, okay? So I included there my fixture, and my fixture is placed on a dolly, and I got some robot arms there. I got my CNC machine there. I even got an entry there with a rack with some parts. So let's suppose that this are the parts I need to work with, right? And I want to check, or I want to manage how this layout looks on my actual factory, okay? So this is what factory design utilities is for, okay? So if any of you guys and girls out there probably has done anything like that, you'll probably know that the easiest way to manage all of this is from our 2D view, right? And Inventor is meant to work with 3D models, right? So the advantage of me being able to jump from AutoCAD and Inventor and having all of that linked and manage all my assets, it's very, very powerful a tool to have, right? That's what factory design utilities is for, okay? Factory design utilities appears as my factory tab here, right? And it appears also on other software as well. For example, I got AutoCAD architecture here, where AutoCAD is part of the manufacturing collection. So with PDM, I got AutoCAD, I got Inventor, and I got all the versions of AutoCAD that are out there in case one works better for me. So if I want to work with AutoCAD Mechanical or with Plant 3D, or if I want to work with AutoCAD Architecture, I got all of them in the collection, okay? So in this case, I'm working with AutoCAD Architecture, right? and I got the layout there, and I got all the tools from AutoCAD architecture to work on my layout. Okay. In this case, also, if I'm working that I want to move this part a little bit to the center of the dolly. Sorry. Now let me bring my new part assembly. There we go. Oh, sorry. I'm gonna bring this here, and I'm gonna place this a little better here and there. A little center. It's a very, very basic thing, right? But it's a change that I made in Inventor, okay? And I want to work with the 2D layout. I want to use the tools from AutoCAD architecture, okay? Connect the model, the project, if you will, with the factory design utility, okay? So I'm going to jump to AutoCAD. And there we go. We get our part here. We get our moved part there. And if I want to keep working with AutoCAD, let's say that it's easier for me to arrange my part there, I can do that as well. For example, I can set up this machine as an asset, right? I can move it a little to the right. I can move it a little down. I can change the information that I get for this asset. You see that with factory design utilities, I can create libraries of stuff that I want to bring into my model, right? That are not just placed, or they're not just 3D models, but there are information that I can set up as well. So for example, I can bring in parts from the library from Autodesk. Let's bring in an operator there for my CNC machine. Okay. Let's bring in, let's say, material handling. Let's bring in a forklift. There we go. And I'm gonna check the properties of my forklift. So let's say that my forklift is a little wider, right? Let's say that, let's see, we got the truck width, for example, 45. It'll take a little bit to update. But anyway, with factory design utilities, what I'm doing is I'm setting up my assets and managing all my factory from a single hub, right? So there we go. We get a wider truck, right? And I'm going to save this. And I'm going to open that one in Inventor. So there we go. So we got the rust there. Well, in this case, it takes a little while. While it updates the 3D model, because it needs to bring it in, and it's going to take a long time. But for now, what was updated here was the model in AutoCAD, all right? So I got information between the software there, and I got many, many other tools. For example, I can analyze workflows. I can analyze material. I can analyze downtimes. I can manage my factory from AutoCAD as well. I can do all of that with factory design utilities. Okay, so this is on a larger scale. All right, and like as mentioned, we get AutoCAD as well for our as a general purpose tool for anything that we need. For example, if we want to work with, if we want to work with our layout, or if we want to work with, let's say, the DXF from our bracket. Okay. Let's say that I need to modify this. engineering data bracket 1, let's say. Oops, that's bracket 1 already exists, so bracket 2. Now let's leave the general configuration, and I'm gonna open regular AutoCAD because I need to modify something, because I need to work on it or something like that, right? So I can use all of those tools for any part of my design and manufacturing workflow, right? So I get AutoCAD here, and I'm gonna open bracket I just exported, a DXF, okay? So if you need to modify this, let's say that I don't want to have the bend lines, right? Or I need to set up this on a different layer to send that to a CNC machine or something like that. I'm gonna apply it here on red. There we go. I'm gonna place all of that under CNC. So basically anything that I need to do on AutoCAD, I can do that as well because AutoCAD is part of the product design and manufacturing collection, right? Let me close this one here. And lastly, one couple of things. If we want to manage all of that information, if we want to manage or if we want to have control, that's a better phrasing for what we want to do here, of the revisions for this. If we want to save that to a secure location, all of that, we got Vault as well, okay? So with the product design and manufacturing collection, we get Vault Basic. So in this case, we get check-in, check-out features, right? So if you're working on this, Jimmy cannot make a change, or Sophia cannot make a change. Just JD can work on that. And later on, if Sophia wants to make a change, she can do that as well. So in this case, I made a change. This file was locked out from Vault, right? So I'm gonna check the file again. I'm gonna check it in again, right? So in that case, the file is secure on the Vault, everything's managed from a single location, and no one in my team can mess it up. So I got that functionality too with my product design and manufacturing collection. Or let's say that I also want to use all the tools from Fusion, okay? So in this case, what I'm gonna do is I'm gonna send this file to Fusion because my model, my original design was actually on Fusion, okay? So this was something that I created there, and I'm gonna send this right here. Come on, let's load up. There we go. I'm gonna include that new design here, there, okay? So from Inventor, I can, okay? Oops, I need to check it out. Sorry. Yep. There we go. Check out Fusion. Let's send it up. So this is bridge new. I'm gonna place that in my Fusion team under guitar. There we go. Upload. There we go. So let's open it up in Fusion. There we go. So there's our part uploaded to Fusion, right? I had that one included in my webinars folder. So I can include that part into my Fusion line. Okay, so bring it up here. Go. And this is my replacement part there, so I can pop it up here. I'm not gonna delete the older one. This was like a conceptual thing, but this one is a new one that I made some changes from. Okay, so I can include all of that. I can send information between Inventor and Fusion, and I can use this this model here in Fusion that I have available in Fusion. So if you want to work, or if you get the extensions on Fusion and you want to work with generative design, or if you want to run a simulation, you can do that in Astron as well, right? But maybe you get a workflow configured in Fusion as well with simulation, or if you want to do rendering, or basically just handle it from, you can do that as well. Okay, so that's all you have with the product design and manufacturing collection. A whole set of tools basically for defining what you need, or for any step on the design and the manufacturing work. I almost forgot about our latest tool, which usually it's a tool that most of the people don't care a lot about, because this one is from our media collection, okay? But it's a very, very useful tool that I'm pushing for more people to know about, which is 3ds Max. So this one is mostly used for the entertainment industry, creating models, creating renderings, those kind of things, right? But in this case, it's very, very useful to create very realistic representations of our products, okay? Creating catalogs, creating virtual models with our VR headsets, for example. I can do all of that from 3ds Max, okay? In this case, well, this is a whole new world, right, in 3DX. We're one that we're looking into as well, and that I hope more people will get into as well, because basically I believe that not only in terms of marketing, but also on even review, design, and all, it's going to be part of the future. Basically, all of the most advanced tools we got there, we got them available with 3ds Max, and that one is part of the manufacturing collection as well, right? So basically, that's what I wanted to show you here. I tried to be as concise as possible, but you see that there are lots of tools there, and we haven't even scratched the surface of what all of them can do, right? If we're looking at an Astron, the analysis I run was just a simple static structural one, right? We can do many types of analysis. With Inventor CAM, that's a whole new world. We can do 5-axis machining. We can do more complex simulations. With factory design, we can manage, not only create assets like we did here and exchange information between AutoCAD and Inventor, but we can also analyze how we can handle our materials, make calculations, basically like this lightweight ERP software, if you will. So basically, with the PDM collection, the world is your oyster. You can go as far as you want. All the tools are there, and basically, there are two, so you can tackle the design and manufacturing of a product in any way you want, at any stage you want. All right. So that's basically it for me. If there are any questions, I'm open to those.
Thank you, Jose. That was very, very complete. And as you just said, we barely scratched the surface. So please let us know if you would like to see a series on this. Maybe we can further develop something like that. And yeah, you can ask a question on the left hand side. And I will start with the first question. Um, does Fusion include all the extensions with the PDM collection?
Okay, so in this case, no. I mean, Fusion it's its own world, and with the PDM collection, we get the Fusion software, right? But Fusion by itself is a whole new environment. And with Fusion, we get some extensions depending on what we're trying to do, right? So we get a manufacturing extension that has different capabilities from the Inventor can, right? Or we get simulation, or we get signal integrity, or we get managing software. So that's a whole new set of tools that are very, very specific, and Autodesk has them available so you can get exactly the ones you need, okay? So the PDM collection is very, very complete. It gives you the option to include Fusion as well, and it includes the option to configure Fusion with what you actually need. Okay, so the extensions are sold separately, but basically it's so you can configure your Fusion setup in the way that you want. If you get some functionality in the PDM collection already, for example, if you're good using Nastran, probably you don't need the simulation extension, right? So basically, it's all there.
Thank you. And I'm gonna go for the second question I see. Are all products that we sell today available individually? For example, can I purchase just Inventor Cam?
Okay, no. There are some products in the manufacturing collection that are available just by themselves. For example, Inventor, you can just purchase Inventor, or you can just purchase AutoCAD, or you can just purchase Fusion, right? But the ones that are kind of included in other software, for example, Inventor Cam, it's not software by itself. It's like an add-on to Inventor. Those ones are part of the product design and manufacturing collection. So you only get them when you get the whole collection. Okay. So tolerance analysis, Nastran, Inventor Cam, FDU, nesting are available just through the manufacturing collection. The thing is, if you get Inventor and you want to purchase AutoCAD or something like that, it's a way cheaper option to get the product design, the whole collection, instead of purchasing them separately. Okay, so it's a better option in general to get the whole collection. You get all the tools, and basically, obviously, chances are that most people won't use them all, won't use all of them. Okay, but I think it's important to know what tools are available, because you might not be even aware that they exist. Okay, for example, I've seen many people find tolerance analysis very useful that they just didn't know that they had it, right?
Got it. Thank you. And yeah, I would like to remind everyone that we offer custom training. So if you want to learn this topic in depth, we can always offer you a good deal with Jose or someone else on our team. And regarding Fusion, now that we're talking about manufacturing, we will have another webinar with Jose about Fusion extensions. That one will be on April 10. And then on April 4th, which is next week, we will have the continuation of our Bluebeam series, from setup to success, Bluebeam software setup. So yeah, I don't know if there's any more questions, and if there are not, Then, yeah, I would like to thank Jose for this great presentation. It was very complete, although we know it was just the surface. And thank you, everyone, for attending.
Thank you, Helena. Thank you, everyone. Hope this was very, very enlightening. And yeah, hope
It
to
was.
talk to you soon, right?
Talk to you soon. Bye bye.
Okay. Bye bye, Helena. Bye bye, everybody.